Hello everyone, this is GATE 2023 Life Sciences Biochemistry. Question number 36. Intracellular concentration of ATP, ADP and inorganic phosphate in 4 cell types are given below. Which one of these cell types has the most negative delta G for ATP hydrolysis? Okay, so these are the different cell types L, K, B and M. And these are the respective ATP, ADP and inorganic phosphate concentrations given in millimolar. Okay, so and this is the NPTEL online course reference in which they have explained Gibbs free energy, entropy and bioenergetics. So in the question they are asking among these cell types which has the most negative delta G value. Okay, so what is Gibbs free energy? Denoted by this G. It is the amount of free energy required to do a work. So in cell we are talking about energy required to carry out different reactions, right? So we have n number of reactions occurring in cells. So the energy required to carry all these different reactions is the Gibbs free energy. So in case, for example, let's consider ATP hydrolysis. So ATP is hydrolyzed to ADP and inorganic phosphate. Okay, ATP hydrolysis is highly exergonic process. I'll explain what is exergonic process. Also known as spontaneous reaction. Why? Because ATP has adenosine bound to 3 phosphates. These are the 2 phosphate and the third phosphate is attached via this very high energy bond. Right? And when this high energy bond is hydrolyzed with water molecule, it is broken down to ADP and PI. And when it is hydrolyzed, it releases lots of free energy. Okay. And this energy is further utilized in cell for various purposes. ATP is the main energy currency of the cell. Okay. So if we see the reaction progress curve for ATP hydrolysis. So here we have how the reaction is progressed against free energy, which is Gibbs free energy. So at the starting we have ATP molecules and Gibbs free energy is increased, reaches transition state and products are formed. So here we have ATP and here we have formation of products, that is ADP plus inorganic phosphate. Okay, and this is the free energy of reactant and this is the free energy of product. So at standard conditions, so what are the standard conditions? When the ATP concentration is 1 molar followed by at 25 degrees Celsius and at pH 7. So at 25 degrees Celsius and pH 7, when we use 1 molar of ATP to get 1 molar of ADP and 1 molar of PI, the difference between the reactant free energy and the product free energy is referred to as This difference is referred to as delta G naught. This is Gibbs free energy at standard temperature pressure conditions. Okay, so this delta G is Gibbs free energy of product minus Gibbs free energy of reactants. This is pretty simple. So this delta G naught, when is negative, it is known as exergonic process. Is exergonic process or spontaneous reaction. As I mentioned here, it is exergonic or spontaneous. Okay, and when this delta G naught is positive, it is endergonic process or non-spontaneous. Okay, and why is this important? So all the reactions in order to be feasible, that is spontaneous, so in order to carry out a particular reaction, it needs to have delta G to be negative. If it has positive delta G, then we have coupled reactions in which the overall delta G is eventually negative, and thus the non-spontaneous reaction are coupled to spontaneous reaction inside the cell to make them exergonic. Okay, so in order to understand whether a reaction can be spontaneous and non-spontaneous, we have delta G naught values. Okay, and this can be estimated using a mathematical formula given by delta G equal to delta G naught plus RT ln Q, right? So this delta G is the change in free energy, which is equal to Gibbs free energy at standard conditions plus R, which is a constant at T temperature in Kelvin, natural log of Q. Q here is reaction quotient. So what is reaction quotient? Q equals to product of reactants. Here, for example, in this reaction we have ADP and PI. Sorry, product of the products form, that is ADP and PI, upon reactant. So the reaction quotient is product of ADP PI upon the reactant, which is ATP. Okay, this is the reaction quotient, and at K equilibrium, that is when the reaction is in equilibrium, which is rarely occurring inside the cell, delta G, this value becomes 0, and then we have delta G naught equal to minus RT ln K equilibrium. So these are from the question, these are the different concentration of ATP, ADP and inorganic phosphate. So let's start with first cell type L. Okay, so for L cell type, what will be our Q? So I'll write the delta G formula here. We'll have to refer delta G naught plus RT ln Q. So we'll first compute Q. So Q will be 1.8 into 5, right? Product of the products formed upon reactant, which is 3. So this will be how much? 3, right? So the for L cell type, the reaction quotient is 3, and when we put this 3 in this formula, we'll have delta G equal to minus 30.5 plus RT ln of 3. Okay. So you can compute what is RT. It will be around, I calculated approximately, this is around 2477, and the natural log of and the natural log of 3 is around 1. Okay, so the final answer will be, it will be something positive. Okay, why? Because this minus 30 plus 2477, it will be something positive. So it will be a positive value 2466, right? And in the question they have asked, which of the following cell type has most negative delta G. So this is out of the option, because this will never be the answer because it has positive delta G value. Okay, so this option is gone. Okay, so next we'll move to K cell type. So for K, we'll compute the reaction quotient. It will be 1.3 into 3, right, upon 1.3 into 3 upon 3.9, and it will be 1. Okay, this will be 1. And so anybody knows what is natural log of 1? What is natural log of 1? Yes, log of 1 is what? This is very simple mathematics. Natural log of 1 is what? Yes, it is 0. So this whole term will be 0 by default, and we'll be left with delta G is equal to minus 30.5. Okay, so we got this as minus 30.5. Now let's compute B cell type. So B cell type reaction quotient will be 0.7 into 2.7 upon 2.7. So 0.7. So delta G will be minus 30.5 plus RT ln 0.7. So if we calculate this, it will be minus 30.5 plus. So if you like pay attention, if any value which is less than 0, so this whole value will be in minus. Okay, so this will be minus RT is around 2477 and natural log of, so if you take natural log of something 0 point something, it will be always in minus. Okay, these are the few things you should know. So the natural log of 0.7 is minus 0.35. I'm bringing this minus outside. So this will be minus 30.5 minus 7.45. Okay, you guys also calculate this. So the final answer will be 37.95. Okay, we got a higher number, 37.95. And finally for the M cell type, we'll have 8 into 0.9 upon 7.2, right? This will be again 1. So we already computed for 1. This is also 30.5. So the highest order of magnitude of delta G is B cell type. Okay, so the answer is B. Any questions?